The concept of a warp drive-powered spaceship has been a staple of science fiction for the past several decades. A way to travel at speeds faster than light without any drawbacks, like time dilation or a need for hypersleep. It is perhaps most famously used in Star Trek, which has gone to great lengths to explain how it works within the fantastical framework of the setting. For decades, scientists viewed this propulsion concept as the realm of pure fantasy. This all changed in 1994 when Mexican physicist Miguel Alcubierre released a paper that argued that it was mathematically possible based upon Einstein's equations. However, there were practicality flaws in Alcubierre's study, as the warp drive as he described it would require astronomical amounts of energy to work. The paper also did not describe how the method of propulsion could be engineered. Nevertheless, in the last 25 years or so since the paper was published, there have been many scientists who have built upon Alcubierre's breakthrough findings. These scientists have focused on figuring out ways to bring down the energy requirements of the warp drive, and have even taken steps towards envisioning how such a spaceship equipped with the warp drive would look and function. The warp drive, as depicted in science fiction and as fleshed out in Alcubierre's mathematics, moves the spaceship by the simultaneous contraction and expansion of space. The fabric of space and time expands behind the spaceship and contracts in front of the ship. The expansion of space behind the ship essentially moves the bubble forward, while simultaneously the space in front of the ship is contracted to the point that the destination itself is being shifted closer to the bubble. During the process, the ship itself remains in a kind of stationary freefall within the bubble. Therefore, nothing within the bubble is actually moving, and as a result, not only do the occupants of the spaceship feel no movement, but they also experience no time dilation. Time dilation is the real-life phenomenon that occurs when objects moving at high speeds, especially those approaching near the speeds of light, experience time slower. Any hypothetical spaceship using a propulsion system that requires actual movement at speeds approaching the speed of light will thus subject its occupants to the effects of time dilation. This brings up many practical issues, as there would be many situations where astronauts would return home from voyages still looking young, whereas everyone back on the home planet would either be elderly or long dead. Unless time dilation is an important plot device in one science fiction story, this effect is generally seen as undesirable for both the science fiction writer and the aspiring warp drive engineer, and thus warp drive is seen as far superior by both. Based on Alcubierre's calculation, the warp bubble containing the spaceship would be either spherical or ovular in shape. There are three main areas of the warp bubble that have been theorized: the inner passenger area, the wall or warp shield, and the outer warp drive shield. The warp shield is made of some durable but as yet unknown material, while in the immediate outside areas of the warp shield, one will find a surrounding gravitational field. As one moves further out, this gravitational field steadily grows weaker before eventually dissipating to normal space-time. Alcubierre's paper in 1994 was groundbreaking in that it proved that the warp drive was mathematically possible. However, Alcubierre knew that the idea was unfeasible from an engineering standpoint, as his warp drive would need an astronomical amount of energy to work. He also did not make any mention of what kind of energy needed to be used, nor did he explain how such a device could be built. Recent work by scientists have sought to bring down these enormous energy requirements. It has been hypothesized that a torus or donut-shaped warp bubble would bring down the energy requirements significantly, though even with this new development, the required energy remains absurdly high. A form of energy called negative energy has been seriously explored as a potential candidate to power a warp drive. It may be possible to produce such an energy type using a real-life phenomenon called the Casimir effect. The Casimir effect is named after the Dutch physicist Hendrik Casimir, who postulated in a 1948 thought experiment that two uncharged and perfectly conducting plates, when placed within a vacuum less than a micron apart from each other, will be drawn together. In classical Newtonian physics, the only force that should be acting on the plates is gravity, but for microscale objects, these forces appear to have little effect, and the laws of quantum mechanics take over. This theory is largely dependent on the concept that a vacuum is not empty and is actually teeming with an infinite soup of subatomic particles. Even in empty space at zero temperature, virtual particles like photons are continuously flickering in and out of existence. In the environment of a vacuum, the infinity of particles outside of the tiny microscopic space between the metal plates becomes greater than the infinity of particles between the plates. Thus, a negative energy is created between the plates that pushes them apart, while a simultaneous force pushes the plates together. But after a period of tug-of-war, the forces that push the plates together ultimately win. For many decades, this theory existed only in mathematical equations, proven as feasible but impossible to replicate in a laboratory setting due to limitations in technology at the time. In Alcubierre's 1994 paper, he proposed that the Casimir effect and the negative energies associated with it were a possible means to make his warp drive work. Remarkably, in the late 1990s, nearly 5 decades after Casimir first talked of his idea, engineers proved the Casimir effect to be a real-life phenomenon when they replicated and observed the effect on a microscopic scale in a lab. Though the Casimir force has been observed in a lab with nanoscale plates repulsing each other, the force has yet to be applied to any practical application. A proposed practical application is preventing the various parts of nano-sized machines from sticking together. Scientists predict that reconfiguring the shapes of the plates can orient the plates to either stick together or to repulse each other. It has been theorized by many scientists seriously exploring the warp drive that a kind of spaceship that somehow incorporated the Casimir effect could create a warp bubble. The negative nature of the energy of the warp bubble could also serve to solve many practical real-life issues relating to space travel. One danger is that debris in the path of a spaceship can cause structural damage. However, the negative energies would create a negative mass on the cusp of the warp bubble, which would in turn gravitationally repulse and deflect all matter that comes into contact with it. No known object in the universe is known to have a negative mass, but if such an object were to exist theoretically, it would behave in an opposite way compared to regular mass. Regular mass in the vacuum of space will pull objects of lesser mass towards it, whereas an object with negative mass will repulse objects with smaller regular mass. Conversely, two objects with negative mass will attract each other. The enormous amounts of negative energy generated by the warp drive could also have some practical issues, as it has been hypothesized that as soon as the warp drive ship reached its destination, any objects in the vicinity of the ship would be obliterated. This would be caused by the buildup of particles in the warp bubbles, particularly in the regions in front of and behind the ship. As the warp drive ship decelerates from faster than light speeds, the trapped particles will be unleashed in violent outbursts. The particles trapped in the front will be the most energetic, and will destroy anything with gamma rays. The length of the journey using the warp drive can influence the intensity of the destruction, but there is potentially no limits. This issue, however, could be solved by the addition of conventional rocketry, or some other type of more stable propulsion system aboard the spaceships. A warp drive pilot could stop his ship at a safe distance from its destination and then traverse the remainder of the journey with other propulsion methods. Just as a jet will take off and move at subsonic speeds away from any urban areas until it is at a safe distance in altitude to exceed the speed of sound, a warp drive ship will have to leave a planet at subluminal speeds and likely have to exit the planet's star system before it could safely engage its warp drive. The navigational system aboard the warp drive ship would also need to calculate routes that are not near any planets, as there would be moments even during the journey where enormous releases of explosive energy could occur. For example, if a warp drive spaceship had its warp drive engaged and is moving 200 times faster than the speed of light on its way to a distant star, and it moved through an interstellar dust cloud, many particles of dust would get trapped in and around the bubble. If the ship were to then soon afterward go through another interstellar dust cloud, the particles being dragged along would collide with the second dust cloud, causing enormous releases of energy that could still likewise damage planets. The addition of some other means of propulsion other than a warp drive would be an absolute necessity, as some scientists have said that the warp drive ship would need to be already moving before the warp drive could be engaged effectively. Although it is conclusively acknowledged by all that a theoretical warp drive spaceship would move at speeds many times faster than light, precisely how fast in numerical terms the spaceship could go is an open question. However, Dr. Harold G. White has speculated that a warp drive spaceship could go from Earth to the Proxima Centauri star system, which is the closest one to Earth, in less than 6 months, despite it being about 4 light years away. This computer-generated image of a spaceship you see here is an artist rendition done by Mark Redemacher of a spaceship incorporating the warp drive. It was created by the artist in collaboration with many scientists who have been studying the hypothetical propulsion method, especially Dr. White. The image is not a simple artistic rendering of a technical idea created over a short period of time with wide artistic license. Instead, it took years to create the ship depicted, and thus, as of the creation of this video, it visually incorporates on a highly technical level all of the latest research into the field. One technical detail that will be readily apparent to those familiar with the latest warp drive theories are the two rings at the front and back end of the ship, which are designed to reduce the energy required to generate a warp field. Despite all these conceptual advances on the drawing board, figuring out a way to control the warp bubble once it is created around the spaceship is a huge problem. Many scientists think that it will be impossible to control once it is created. However, some scientists have proposed that the spaceship could send small warp bubbles to the edges of the large warp bubble surrounding the spaceship in order to manipulate it. Due to the negative mass of the warp bubble surrounding the ship, the smaller warp bubbles used to manipulate the larger field likewise would have to be a negative mass as well, lest they be repulsed. Assuming the warp drive engine had a mass that was equivalent to the Voyager 1 space probe, it would require around 63 exajoules of energy. To put this energy requirement into context, it is estimated that annual energy consumption in America is about 94 exajoules. Other studies have suggested that it would take the mass energy of Jupiter to fuel a warp drive, far more energy than what even exists on Earth. According to Dr. White, these prohibitive energy requirements can be reduced by changing the geometry of the warp bubble itself. For example, Dr. White has proposed shaping the negative energy warp bubble to be like that of a donut or torus. Dr. White's calculations have also revealed that increasing the thickness of the bubble, as well as making it oscillate, can also reduce the energy requirements further. Though much of the research so far on the warp drive concept has consisted almost solely of papers filled with equations, NASA's Advanced Propulsion Physics Laboratory, also known as Eagleworks at the Johnson Space Center, has actually done physical experiments on the topic. Over the last several years, Dr. White has worked at NASA's Johnson Center with the Advanced Propulsion Physics Laboratory, trying to get the warp drive concept a little closer to reality. Knowing that actually building such a thing as a warp drive could be centuries in the future, Dr. White and his team have instead focused on exploring the fundamental physics behind the concept on a small scale in a laboratory setting, with the hopes that any revelations could lead to further developments. Dr. White and his team have used a device called an interferometer to run experiments and gather data on the concept. An interferometer is a device that projects two or more beams of light and then combines them using a series of mirrors. A detector then measures the nature of the combined waves, providing data for whatever is being tested. Interferometers have a wide range of applications in science and engineering, and have been used in everything from astronomy, optometry, and seismology. In one experiment, Dr. White and his team created and used an interferometer setup they have named the White-Jude Warp Field Interferometer, which is a modification of the more established Michelson interferometer. A helium-neon laser beam is split into two paths by a beam splitter. One of the split beams goes towards a mirror, which reflects it back through the beam splitter into a detector which interprets data. The other beam goes through a ring that is highly electrified, giving off an invisible electrical field. This electrical field has properties that are loosely and analogously related to those that would be in a hypothetical warp bubble. The hope is that the laser beam going through the ring will be altered in some way by the electrical field. The potentially altered beam would then reflect off of the mirror and be recombined with the laser that had no alteration. The recombined lasers may now have varying wavelengths, that can be measured by a detector, resulting in data that can help make sense of the concept of warping spacetime. The observed phenomenon is extremely subtle and can be easily interfered with. This concern regarding interference eventually prompted Dr. White and his team to move the experiment to a seismically isolated lab, as even people's footsteps outside were interfering with the data. Despite the detection of a difference between the two wavelengths, the results of the test are considered inconclusive to this day, due to external interference and the limits in the ability to process the acquired data. Even though small-scale experiments such as those which have been conducted thus far are a far cry away from the artist renditions of warp-drive spaceships, Dr. White hopes they can help prove some fundamental aspects of the warp-drive concept, which can in turn lead to further research and bring the concept closer to the realm of engineering. Unfortunately, as of the release of this video, the results of the experiments with the White Jude interferometer and all of the other experiments done thus far at Eagleworks have not bore any significant findings. Nevertheless, Dr. White concluded that the Alcubierre warp drive was not just mathematically possible, but also plausible. As for the feasibility of the concept, Dr. White has admitted that the ability to generate negative vacuum energy will require a significant breakthrough in physics. Specifically, a theoretical framework that ties general relativity, which explains how gravity dictates interactions on a large scale, with quantum mechanics, which describes how matter interacts on the subatomic and atomic scales, would also be required as the warp drive concept draws heavily upon both, with its manipulations of spacetime with negative energy. The marriage of these two concepts into a single cohesive framework is called the theory of everything or quantum gravity by physicists and scientists, and has yet to be established despite over a century of research. Dr. White and others in the field also acknowledge that the instrumentation, such as interferometers used to measure the effects of the experiments related to the warp drive concept, also need to become much more sensitive. As is the case with any research pursuing advanced propulsion ideas, Dr. White's fellow scientists have been very skeptical and have written numerous papers pointing out the various errors that led to some of the more hopeful observations that White and his team have made on the experiments, suggesting that there are natural disturbances that are impossible to separate from the phenomenon that they are trying to observe. For example, the skeptics say variations in temperature and the way air interacts with the radiation of the laser can affect the data. In September 2015, gravitational waves were directly observed for the first time, using special observatories which are essentially enormous interferometers designed to detect a change of less than 1/10,000th the diameter of a proton. The event that was observed was the merger of two black holes, becoming one black hole, which produced an invisible but powerful wave across space and time. Since this observation, countless other gravitational wave-producing events have been observed. To researchers like Joseph Agnew of the University of Alabama in Huntsville, such a direct observation further confirms the plausibility and potential feasibility of the warp drive concept, as it raises the possibility that the natural phenomenon of a gravitational wave, distorting and warping space, could be harnessed and exploited by humanity in the same way that electricity was in the 19th century. To Agnew and many others, the discovery also further supports the method of using interferometers to collect data on lab experiments done on the warp drive concept. Meanwhile, Dr. White left NASA in 2019 and joined the Limitless Space Institute, a nonprofit based in Houston, Texas, whose mission is to accelerate the human exploration of interstellar space. The organization was founded in 2020 by astronaut Brian Kelly and aims to encourage the research and development of advanced propulsion technologies through in-house research grants and partnerships with other groups. Limitless Space Institute believes that though they are pursuing very theoretical concepts and possibly erring greatly in the course of the pursuit of such ideas, they still think that revealing insights can be gleaned from these unbounded explorations that may otherwise never surface while sticking to established paradigms. Establishing the capability to send human beings to every destination in the solar system. Think about that. Having an entire solar system of materials and resources would change the very concept of scarcity. Diamond is rare, but if you have a whole solar system at your disposal, maybe that changes the definition of what that is. Second, in order to allow and facilitate human beings to go throughout all the destinations in our solar system, we have to have compact, light, and very energetic forms of power. As we know from life here on Earth, The quality of life is directly tied to how many watts each citizen has at their disposal. Having the capability to travel throughout the solar system and beyond efficiently will also mean that planet Earth will be in a much different position when it comes to generating and utilizing power. It changes the whole concept of scarcity and prosperity. Thanks so much for watching. If you enjoyed my documentary, don't forget to like and subscribe, and check out my Patreon page at patreon.com/World Chronicles.